Welcome back, everybody.
Heyo!
All right, 7.7 already. Woohoo, we love it. We are going to convert to slope-intercept form from other forms of a line. So we know that using all of our algebra skills, we can rearrange all of our terms and make equivalent versions that show us the same information in a different way or make some information easier to access. So if we have a line that's not in slope-intercept form but we want it to be there, which can be very handy because slope-intercept form is an easy way to graph, then we're going to work on how to do that today. So essentially, you're going to see this in the notes here, that the task or the ultimate goal is to isolate y or whatever the dependent variable is if this is a word problem or not just a regular old x and y problem. But in the first few examples here, we're going to work on isolating y. That's all. Okay? So the first thing I want to do is distribute here the 3 over 2 through the bracket. So I'm going to get y plus 4 is equal to 3 over 2 times x minus 9. Now, for my class, I'll do a thought bubble. Thought bubbles are great. Yes, we love them. And for anyone else who wants to see how we got to 9, then here's the info for you. That is not a 3. Okay, let's try that again. 3 over 2 times, negative 6 is what I did here in that second distribution. And so that gives us negative 18 over 2, and I just do some good old fraction multiplication, which gives me negative 9. Okay, so that's how we got to that step. And then the last step is simply to get y on its own. We can see that y is almost on its own here. It just has that pesky positive 4 next to it that we're going to remove by using the opposite operation, which gives us a final answer of 3 halves x minus 13. Voila, it's a final answer. Mr. Side, you're up.
You know it. Sorry, I was just finding my bubbles scene from Finding Nemo.
Ooh, iconic.
Your bubbles reminded me of that.
Very good.
Right?
Yeah,
right?
Totally.
Let's rewind this thing. Play it again.
Yeah, with some volume.
With volume, definitely. Iconic.
Love Finding Nemo.
Anyways, can you all please focus on this example? Thank you. All right. I need to isolate y, and I need to make sure there's no brackety brackets. So let's address all of that. I'm going to do my distribution. 3/5 of x is 3/5 of x. 3/5 of 10. Well, 1/5 of 10 is like 2. So I guess 3/5 of that is, 6. And then just gotta make sure I get rid of this 3 that's dangling on the left. Isolate y. And negative 6 plus 3 is something like that many. Boom. Goes the dynamite. What if anyone else here knows how to do these?
I think I'll give it a try. So here, we have our next question. It's not in slope point form like the previous two, but we're still doing the same thing. All we're trying to do is we're trying to isolate for y. And it doesn't matter which side we isolate it on, we will result in the same answer here. So I know a few of you prefer to have y on the left-hand side because you like that order, by all means, but you could also have it on the right-hand side because it doesn't change. So just to kind of throw things in a little bit of a loop, let's put y over to the other side. So to move that, right now we have plus 2y. So we're going to subtract 2y from both sides, because got to be fair, and figure out that we are left with 5x minus 20 is equal to negative 2y. Okay? From here, we want to get that y alone. Y is being multiplied by a negative 2. To undo multiplication, we divide. And if we divide one side, we have to divide the other side. And we are dividing every single term on that other side, which means the negative 20 gets divided by negative 2, and the 5x gets divided by the negative 2, which will leave us with negative 5 halves x plus 10 is equal to y. And if you're really just feeling you hate that current order, Nothing changes if you were to arrange it in the other direction. Life is still good. Did you feel?
It's 12:34. You should make a wish.
Oh, okay.
Oh, it's me. I forgot. Okay, so let's do this next one here. Again, we have an example where we are not in any of the forms we've looked at so far, kind of very similar to the one that Miss Thibodeau just did, and the same logic applies. We just need y on its own on one side. Doesn't matter which side. So this time, I'm going to move everything else over to the right, just to show you that it doesn't matter. All right,
is that a dolphin?
Okay, so I'll move everything over. And then I need to divide everything by 2. Remember that means I'm going to divide each term by 2. Okay, so not just the first term or not just the second term, but every single term. Okay, so I'm going to get negative 3 over 2x, and negative 8 divided by 2 is negative 4. And that's it, that's all. We actually already finished the whole question. Awesome.
Easy with them scroll-ins there.
Yeah, sorry about that.
Hey, it's okay. We all make mistakes sometimes. Easily rectifiable. My mistake is not picking a color in advance.
Rookie.
I know. This will work. All right. All them same things. Need to isolate y. I can do this. I will do this. I'm going to say that 2x minus 9 is positive 8y. I know it looks a little backwardsy, but I just like to keep y on its positive side. It's negative 8 on the left. I don't know. I prefer positive 8 on the right. That's where my heart takes me. So I do that. And then, of course, I'm going to divide all this by 8. Don't you try to tell me who I am. I change every single time I do something. Don't write my 2's consistently. What are we doing here? I don't know. This thing is just y. And this other stuff, 2 over 8 is some stuff. Negative 9 over 8. Oh, whoop, variable. I was doing that to show you mistakes that are often made. And that's one of them. Make sure you include your variable. Did it on purpose. And this is done. So close. Can I move it like this? Yes.
All right. Last and final example on this page. And we're going to pick a color because that's what math is all about. And we're going to pick orange. Ooh. All right, so taking a look at this guy here, same thing goes for this question as every other question that we did in this lesson, is we want to get y all alone. I, too, enjoy having y on its positive side, but like to throw a wrench into things from time to time, so I'm going to just move y over to its negative side to show you that it's a-okay. So we are going to subtract 6y from both sides. That way we are left with 3x minus 12 is equal to negative 6y. To get y alone, right now it's being multiplied by negative 6. We undo multiplication by division, and we do that to every single term. Those negative 6's go bye-bye on our right-hand side with the y. And we are left with negative 1/2 x plus 2 is equal to y. And you could go ahead and rearrange that if you so desire to give us y is equal to negative 1/2 x plus 2.
Okay, next page. Now we're going to look at some word problems. Everybody's favorite. Okay, so when we have word problems, just want to remind everybody that establishing the rate of change, as is worded in the notes, is finding the slope. And then we can find the dependent variable's intercept, which is equivalent to the y-intercept in our graphing, if we were to graph this by finding its value when the independent variable, is equal to 0. Okay, so that's just over here in the notes if you need to refer back to it. All right, let's start this one off. So we are going to determine some appropriate variables, and we're going to do some calculating. Now, because we're in our linear relations unit, just a reminder that our word problems are going to represent linear situations, which means that we know that this cost of the taxi ride is going to increase at a constant rate, so we can find a slope because we know that it will always be going up by the same amount. And so because of that, when you find the slope, you can actually use any two sets of points, data points, to find that slope. So it's okay if you wanted to pick different points than I did. That will give you the same answer still. All right, so speaking of slope, let's work on that. Okay, so when I am doing this example, I'm just going to pick this first point where distance is 1 kilometer, and then also where distance is 0. Okay, so that's just what I picked, but like I was saying before, if you picked other points to do this work, you're going to get the same answer as I am. So I'm going to plug this in. Okay, so $6.30 is the same thing as 6.3 minus 5.1, as again represents $5.10, and then 1 minus 0 in the denominator. To go over that quickly, we know that the distance is going to be our independent variable, and so that is why it's like our x, so it goes in our denominator of our slope calculation, and our cost is the dependent variable because it depends on how far the taxi has gone, and because of that it's like our y equivalent, which is why it goes in the numerator of our slope calculation. So just to make sure we get both of those straight so that we get them in the right spot in our slope. All right, so when we do that subtraction, and then we're going to get 1.2 over 1, which of course just simplifies to 1.2 as our simplest form. So that's our rate of change, or our slope. And then we are going to figure out the b value, which is our y-intercept. So again, we're saying when the independent variable is equal to 0, what is the dependent variable equal to? So in this case, it's just right here with $5.10, which we can represent as 5.1 when we simplify it. Okay, next thing, we need to assign some variables and make an equation for this situation. I like this color. Okay, so I'm gonna do some let statements. Okay, so I'm gonna let C represent the cost, and because it is in dollars on the table, I'm also going to just keep that the same. No need to change it. And I'm going to let D represent the distance in kilometers. Okay, so then based on that, then I can say that the cost is equal to rate of change, which is 1.2, and times dollars, plus that y-intercept equivalent, or that 0 number, and to line that up with our y equals mx plus b, that's like saying the same thing, just again reminding you that this is a contextual problem, so that's why we don't have x and y, but c and d represent those same things, where the d is the distance, the independent variable, and c is the cost, the dependent variable. So that lines up exactly with what it would look like if it were just x and y on the graph. So there we go, that's a final answer. Can put a box around that.
In our lastest example? Yeah, it is. Mr. R is tracking his sick gains. Classic Mr. R. Classic gains. He's bench pressing things. He's bench pressing so much. What are you doing? Get out of the shot. His bench press results are shown in this table. So we're going to model his weight benched based on the number of weeks that have elapsed. And if we check this thing out, just to make sure it actually is linear, these are always going up by 3 every single time. These are going up by 15 every single time. We've got a constant rate of change. So yes, this thing is linear. Info we can extract in another shade of purple is that when 0 weeks have elapsed, the weight is 135, which gives us a nice starting value. Right away we can tell that our y-intercept, or our dependent intercept is at 135. For the slope, let's pick any 2 points. Maybe this business, I should circle that differently. This is 1 point. This is another point. And we can use those. So it seems like as an average, he's increasing the weight by 5 pounds every week. Totes realistic. Let's go. We have the intercept. We have the rate of change. Let's pick some variables. Let's be done. I will choose W for the weight. Which is measured in pounds. How do you spell and? I don't like my writing, it's fine. And something for the number of weeks elapsed. Well, I can't use W again. When it's number of something, I always like to use N. That's my general go-to. So in this case, it's usually y equals mx plus b. It's not y this time, it's w. That's our dependent. M is 5, not x. Our independent variable is n, the number of weeks. And plus b, which in this case is 135. Boom, diada. That concludes that example, which concludes this whole section. You might have noticed at the end of this section, as a real change of pace, we have some practice work. No, just kidding. We always have that. So if that's a surprise, surprise, but it shouldn't be. Yep.
Okay, bye.
See ya.
Au revoir.